we're trying out a new mic today. We'll see if that takes care of our sound issues, but here's what we're doing. Remember, guys, we gave you the extra assignment right before spring break because we said we didn't want you to come back to a test. This is the last chapter, last topic of the section. So that means on Thursday we'll have our practice test, meaning we'll do the end of the topic test next Monday. So just be ready. This is the last piece in this. So we're going to kind of wrap up a lot of what we've been talking about, just to help you guys remember all of it. We're going to apply properties of operations to create equivalent expressions. We're going to use properties, tables, and graphs in order to see if things are the same. You're going to identify when two expressions are equivalent and determine whether two expressions are equivalent. So as you can see, there's a lot of that same word in here in today's lesson, right? Today is all about equivalence. In other words, things. Do they equal the same thing? So we're going to start with a quick review. We've given you two sets of numbers. We'll go ahead and check and determine which ones are equivalent and then explain how you know. 4 problems. We've got about 4 minutes on this one.
7 is equivalent to 100 to 140. Asher?
See if you can multiply 5 by something and get to 100. See if you can multiply it by 7 to 100.
Okay, so what am I multiplying 5 to get to 100?
20.
And 7 to 140?
20.
Are they equivalent?
Yeah.
Yes, because I'm multiplying by the same number. It says, explain how you know. All right, I'm giving you about 2 more minutes to do this for those of you that were sitting there not knowing what to do. All right, 42 to 48, 14 to 15. What do I do to 42 to get 14? Divide. Divide by? 3. What is 48 divided by 3? 16. Are they equivalent? No. No, because we have 15. That's not the right answer. No, not divided by the same number. Guys, how many times have we done equivalent ratios, equivalent fractions, all of these things that are equivalent so far this year? Every quarter. The whole quarter? A whole month. So we're still doing it. So that tells you that equivalent things is important? Yes. It's time to figure out how to get equivalent things, guys. This is ridiculous. $105 to 100, 20 to 21. What can I do to 105 to get you 20? Well, first of all, it's getting smaller, so I'm not multiplying. Divide. Divide. Not evenly, but it does work. I can divide by 5 and 1/4. I believe. Yeah. Oh my God. So now I need to see if that works with 100. How do I divide a whole number by a fraction?
Make the whole number a fraction by making it over 1.
Over 1, and she said slam dunk for the mixed number. So I have 100 over 1 divided by, what's 4 times 5? Plus 1? Now how do I divide fractions? Leave change, flip. Times 4 over 21. So 100 times 4?
Equals 421.
Over 21. It is improper, so I'm going to divide. Can 21 go into 4?
No.
No. Can it go into 40?
Yeah.
How many times? What do you notice about our whole numbers?
It's 1.
We have 2 whole numbers. We have 1 for this one and 1 for this one. What do you notice? Is 1 and 5 the same thing?
No.
They're different. So that means they're not equivalent. All right, and the last one. 9 to 12, 16 to 80.
Oh.
Not sure.
He's thinking. What do you think?
Like more than one. It's in the teens.
What are you talking about? Oh, I stopped because the whole numbers are different. But I don't need to. All right, what can I do to 9 to get to 16?
Multiply.
I'm multiplying.
I can't multiply.
Can it go evenly?
No. Oh man, not again.
So let's see how many times I will multiply. 9 goes into 16 how many times? That's 64. Leave 6.
It just gets repetitive.
So I have 6 and 6 ninths, because that's my remainder. So 6 and 2 thirds. Let's see if 12 times 6 and 2 thirds gives me 80. What do I do?
No, you have to make it. You have to make it.
3 times 6? 18 plus 2? 28. So I get 12 over 1 times 20 over 3. 12 times 20?
I can't. 2,400.
12 times 2 is 24. Add a 0. I was trying to make it more simple. 1 times 3? 3 goes into 24. How many times? 8. And add a 0. So did I get the same answer? So that means I'm multiplying by 6 and 2 thirds on this side. Are they equivalent? Yes. That's why you have to work them out and not guess. Guessing is not going to get you anywhere near the right answer. Is that my response?
Okay, everybody show obey your highlighters. Turn to the next page. Our first one, we got our definition. It's really important. We talk about equivalence so often. You're seeing that's what this whole lesson is about. It's on like 5 of the 4 bullet points. Start the lesson. Okay, what are equivalent expressions? It means when any values are substituted for the variables, the results are equal. So easy way to say it. When I put the same number in, I get the same answer out. That means it's equivalent. In order to determine the equivalence, it's not realistic to test every possible one, but you can examine the characteristics from different representations. You can do a table, you can do a graph, or you can rewrite the expressions using properties. So that's why Mr. McCann and I are about to hand out a whole sheet of properties for you that are going to help you to understand what properties we put, mathematical properties in order to justify switching the format for our answer. Right now, but while she's doing that, I'm going to go ahead and get you guys started on this. Our first thing we're going to do is complete the table for each value of x. In other words, we've given you a value for x. All we want you to do now is substitute that value anywhere you see the variable and then solve. So I'll walk through the first one with you. So I'm saying I'm going to put the 0 here and the 0 there. So I'm going to just rewrite this. 2 times 0 plus 2 plus 3 times 0. Order of operations means I have to do that parentheses first. So I'm going to do 2 times 0 plus 2 gives me 2 plus 3 times 0. Anything I have, I'm going to rewrite. Now I'm doing multiplying. So I do 2 times 2 is 4. 3 times 0 is 0. 4 plus 0 gives me 4. So I'm going to do the same thing on this. But now I'm going to put the 0 in for this x.
Okay.
So 5 times 0 plus 4. Now it's just multiplying. 1.5 times 0 gives me 0 plus 4. Now I add those together and I get 4. So you're going to do that for each of these values. And then you're going to try to answer parts A and B. So we'll give you guys about 6 minutes to get all that done. Get working. Try to do it by yourself first. I don't know a lot of you aren't done yet. We have a lot we still need to get through, so we're going to finish this off. Again, all we're doing, guys, whatever this value is, we're substituting in the expression. 1 plus 2 plus 3 times 1. Now we need to follow our order of operation. Inside the parentheses first. So I can do 3 times 3 plus 3 times 1. You need to be right. I see a lot of lazy people are just trying to do a piece and that's write anything. You're going to lose track of what you've done and what you haven't. Now you do 3 times 3 and you get 10 plus 3 times 1 are 9. 3 times 3 is 9 plus 3 times 1 is 3. That gives me 12.
How do we get 3?
3 times 1.
3.
3. Where we got it from? 3 times 1 is 3.
Oh, we went there. Yeah, 2 times 3 plus 3 times 1.
Oh, yep. 3 times 3 is 6. 6 plus 9 is 9. 6 plus 3.
6 plus
There's where the problem was that 2 out there now. So 3 times 3, which is 6. 6 plus 3 is 9. 5 times 1, 4. Gives us 5 plus 4 or
9.
9. This one, you got 2 times 2 plus 2 plus 3 times 2. 2 plus 2 gives me 4. 2 times 4 plus 3 times 2. 2 times 4 gives me 8. 3 times 2 gives me 6. 8 plus 6 gives me 14. 5 times 2 plus 4. 10 plus 4 gives me 14. 2 times 3 plus 2 plus 3 times 3. 3 plus 2 gives me 5. I've got 2 times 5 plus 3 times 3 gives me 10 plus 9 or 19. This one, 5 times 3 plus 4 gives me 15 plus 4, which gives me 19. So what do you need to determine based on the set of values in the table? What do you notice?
They all have the same.
Rick?
They have the same answer.
They all have the same answer. Okay? That's the word I was looking for. So we're going to put those two together. They are equivalent. Because all of the answers are the same. Okay? So going back to the definition we just gave you. Excuse me. For any value, the results are equal. So anytime I put in a value, when I put in a 0, I got the same value. When I put in a 1, I got the same value. Put in a 2, I got the same value. Does that make sense?
Yeah.
That is your definition of equivalence. If I put the same number into the expression and get the same answer, they are equal. What do you need to know to verify that the two expressions are equivalent? I actually just gave you the answer. When you put in the same value, you get the same answer. So for each of these expressions, when I put the same value in, when I substituted that 3 into both expressions, I got the same answer. That means that they are equivalent. Really can't break it down any simpler than that for you. Just for the record, that's also the answer to your journal entry. Does that make sense? Question? Okay, let's go to our next page. This is where the handout that we gave you is going to come in. Couple parts. You can also use a graph to determine or verify whether 2 expressions are equivalent. So, you check out your completed value from question 1. Oh, look at that. We gave you all the answers on this page. You guys just didn't know it.
What?
All the answers for the previous page are right here.
Thank you.
I'm just glad they did it on a separate page. Uh-oh. Oh, well, it's still there. So, what you're going to do, they're giving you the value. So, just to help you, this is going to be your first Y. This is going to be your second Y. 2 sets of points. So, to make an ordered path of this, all you do, your X value, so this would be 0. My Y value is 4. So, I would give it 0. And I would probably use something different. So, maybe use like a circle for this, and a triangle for this, so that you can see where the 2 points are. And then for the second set, still using that same X value, all the 0 to start, and then my Y value is 4. So you're going to plot all those points for each of those. You're going to draw the lines, plot the values, and then connect the results. So that means we're making a line, yes? What do we use to make a line?
Straight edge.
Straight edge. So use the ruler, guys, when you're drawing your lines. How does the graph demonstrate the 2 expressions are equivalent? And we write the given expressions and identify the property applied at each step. So they've given you, and this is how any proof is going to happen, guys. They're going to start you with a value. That's what we call our given. Then you have to tell me what property did we use to rewrite this, and then fill in the blank piece. And then they told you what to do once you have this piece. So then you can write the answer to the combining like terms and addition on that. So you've got a whole page to do. We'll give you guys about 8 minutes. Go ahead and get started. Do it by yourself first, and then you work with your confusion on how to grab points. Let's go over that first. So how does I make my order here? The first is my X. It's telling me how far left or right I go. Meaning, when it's a 0, I'm actually going to stay right here. But I don't make a dot yet. I wait until I do my second thing, which is going up to 4. So at the 0, I'm going to tell up to 4. Once I get there, now I make the dot. For my next point, now it's going to be 1, 9. Meaning, for my X, I'm going over to the 1. So I'm over right here. But I don't make a dot yet, so I still have to go up to 9. So I come up to 9. Now I make my dot. Next one is going to be at 2, 14. So I come over to 2. I don't make a mark yet. I come all the way up to 14. Now I make my dot. Last one is going to be at 3, 19. So I come over to 3, come all the way up to 19. Now I make my dot. Here's where you pull out your straight edge to make your line. You pull out your straight edge. You put the dot right at the end. You draw your line. It should look something like that. Then I go to my second set of points. At 0, it's going to go to 4. Oh, wow. At 1, it's going to go to 9. That also looks familiar. At 2, it's going to go to 8. At 3, it's going to go to 19. So when I draw my second line, what happens? So guess what happens when I draw the same line to 2 sets of points? What does that tell me?
It's the same.
They're equivalent. Okay. How's the guy demonstrate two expressions are equivalent? The line is the same. if I draw the same line, if they are equivalent expressions. Now, what we haven't gone through yet really is how do you do the property? Guys, this is going to be going, this is algebra. If you've got a good algebra teacher, they're going to make you do this. When you get to geometry, this is what geometry is. Geometry is all about proofs. You have to tell me mathematically how you got from one point to another. So this is the stuff you're going to be doing for years to come. So let's take a minute to give this introduction. You can see I started with this, right? But now they just gave me a 2x. So what did I do? What property did I use? After? Distributive. So I took that 2 and I multiplied it out. We call that distributive property. So mathematically, that's what I did. So what's missing here? I did the 2 times x. What didn't I do? 2 times 2, which is 4. Then they told me I needed to combine my terms using addition. So which terms are the same? The ones that have x's, right?
Yes.
What's 2x plus 3x? 5x. Is 4 the same term?
No.
No, it's a constant. Meaning I've got to keep it separate. What do you notice? When I simplified this expression, what did I end up with?
5x plus 4.
Ended up with the second expression. So when I simplified, are the 2 expressions equivalent? Explain your reasoning. Yes. When I simplified the expression, they are the same. So when I simplify it, when I combine all the like terms I can, when I utilize all the mathematical properties, if I write the exact same thing, they're equivalent. So in simplified form, the expressions are the same, they're equivalent. In a graph, if I draw the lines and the line is in the exact same spot, they're equivalent. In a table, if I have the same input and I get the same answer, they are equivalent. Does that make sense? Xavier, tear it down or you're going to lose it. Aren't you the one that's already hit your head once this year? Oh, that's right. She moved, didn't she? Okay. So now we've gone through it all with you. We're going to give you a couple of different expressions. We want you to do the exact same thing. So you're going to fill out the table. You're going to plot the points. And you're going to use distributive property to rewrite it. You're going to have 8 minutes on this one. Practice.
All right, we are putting the numbers for x in place of x in our expressions and solving. What does 2x mean I'm doing?
Multiplying.
Multiplying. So 2 times 0 plus 5. What is 2 times 0?
0
plus 5?
5.
All right. I am doing it again, putting 0 where 5, sorry, x is. But this time I have parentheses. And according to Gemma, I do those first. 0 plus 5?
5.
What does 2 outside mean? Multiply. 2 times 5?
10. Oh, thank you.
All right. Then I have 2 times 2 plus 5. What is 2 times 2?
4.
4 plus 5?
9.
Then I have 2 plus 5?
7.
7 times 2?
14.
2 times 4?
8.
8 plus 5?
13.
4 plus 5?
9.
9 times 2?
58.
2 times 5? Plus 5? And 5 plus 5? 10 times 2? So now I have all of my solutions to my expressions, yes? So my ordered pairs, I know x is going to be 0 on both sides. for the first one. What is my first y?
5,
And what is my second y?
10,
10. So then I have 2 and 9, 4 and 13, 5 and 15, 2 and 14, 4 and 18, and 5 and 20. Yes?
yes, ma'am.
So now I need to graph those points. So let's look at the first one. It says use a square to represent the first expression. My first one was 0, what?
0, 5,
Okay, so I start at 0. I can't go left or right. Up to 5. And I put a square. Yes?
yeah,
My second one for the first expression is 2 what?
9,
2, 9. So 2 up to 9, put a square. My third one,
4, 13, wait, 4,
4, 13. All right. And the last one,
5, 15,
5 and 15. Then I have my second expression. What is my first ordered pair?
0,
0, 10. Now I'm using a triangle. What is my second ordered pair?
2, 14,
14. Third,
4, 18,
4, 18. And last,
5, 15.
so they look like this. Yes?
Yes.
Yeah.
Where's your straight
I did. What can we tell by looking at our graph?
that the second section is higher.
They are not equivalent because our points are not on top of each other and our lines are in 2 different places. Yes?
Yes.
So they're not equivalent. Okay, so let's look at the next one. It says use the distributive property to rewrite the expression. What is 2 times x? 2 times 5? So let's look at our first thing they gave us. We just did this. Got 2x plus 10. Are they the same? No, they are not the same. They are not equivalent. Which term in the expressions are different?
I don't know.
Which term in the expressions are different? Is it the first term or the second term? Really? Because the first one is 2x. The second terms are different.
But then what's the second?
Second term is what comes after the plus sign. 5 and 10. They're different. Any questions about that? Good. Turn to the next page.
Okay, guys, we're almost out of time, so I gotta go through this quickly. We'll go to the homework in just a second.
Have a seat and you are not taking anything out or packing anything.
But on this one, I'm just gonna go through the middle ones because I think writing out the steps is the hardest part of it. The biggest thing is they've given you something and then not done something on the other part, right? The whole key is figure out what mathematical property am I using to rewrite that. So if I have a number on the outside and then 2 things on the inside, what property does that tell me I'm using? Distributive. That's going to be distributive property. Meaning I'm multiplying this out. So that's going to give me 6x plus 3. And then, like we've done in the other one, once I've got all these terms out here, now we need to put them together. So what's the math term for that? What's the vocabulary? And what property are we using?
Distributive.
Addition. For subtraction, you'd say subtraction. Okay? In this case, I'm putting the like terms together. So I have an x here and an x here.
What is it?
So x plus 6x is 7x, but how am I combining them? Combining them with addition.
Oh,
And then the 3 is still alone, so I just write it like that. Make sense? Okay, so let's go to your homework. Page 397. Explain what it means for two algebraic expressions to be equivalent. We've given you that answer 8 times in the lesson today. It should be a really easy journal entry. Right, here's where you really need to take note. Determine whether each pair of expressions are equivalent. Properties, a table and a graph. So they've given you the table and the graph. They did not give you the properties lines. Let me give you that. When we're doing the properties, I'm going to start in the unsimplified version. So that's going to be my given. So here I would write 2 times 3x plus 2 minus 2x. And this is my given. Then you're going to need to do something to them. Tell me what property you use. Then you're going to put them together. Tell me what you're doing. Just like we did on the previous pages. So I would add that into your notes. So you're going to solve your values. Personally, I would use 0, 1, 2, but they didn't limit you. Whatever you want. Solve them, put them onto the graph. You can do whatever you want. I said that's what I would do. Go to the back page, it's exactly the same. Directions haven't changed, meaning you're going to solve all these. Again, I would use 0, 1, 2, but you can do whatever you want to. Make sure you rewrite this. 2 times x plus 1/2. That is your given. Again, you're going to have 2 steps. You may want to draw that in before you go. Homework will be due on Thursday. Good luck, guys.